Big data can be difficult data. When you're running a pipeline that processes terabytes of data, it can take hours to complete. And if something goes wrong and you have to rerun that pipeline, you're burning several more hours. Today we'll look at incremental loading to process large data sets more efficiently, saving you time and money. Let's dive in. Incremental loading is the lazy man's way of working with large data sets. Instead of taking the full data set and processing it at one time, you take that same data set and break it into small chunks. Then each chunk is processed independently by a separate job run. And when all the jobs are complete, the results are stitched back together to get your full processed data set. The fancy engineers call this partitioning and parallel computing, and it's a method of processing large data sets more efficiently. Suppose, for example, that after your pipeline runs, you find out that the source data was corrupted. Your options are to 1. Rerun the pipeline for the full data set, or if you know that the corrupt data was isolated to a certain chunk, you could rerun the pipeline for just that chunk. Or suppose that your pipeline is designed to capture changes in your source data. When you have incremental loading, you could rerun the pipeline and only focus on the parts of the data set where the source data changed while ignoring the other parts of the data set that are still the same. In this way, you're only running your pipeline for the relevant pieces of the data set instead of rerunning the pipeline over and over again for the full large data set. This is more efficient and cost effective. As you might guess, this makes your pipeline run more quickly. It also uses less compute resources, which can lead to a lower cloud bill. Today we'll look at how we can use incremental loading in Airflow. A core feature of Airflow is something called the data interval. And the idea is that every time you run your DAG, it should process data associated with a certain window of time. When you define your DAG, you have to give at least 3 components. You must give the DAG ID, and then a start date and the schedule at which you want the DAG to run. These 2 components in particular help Airflow determine what data intervals to use for your DAG. In this case, we have a start date of February 1 and our schedule is daily. Airflow will take that and realize, oh, you want this DAG to run every day starting at February 1st, and the data intervals that it creates will match that. Every time your DAG runs, Airflow will pass template variables to your DAG code, and your DAG code can use those variables if you want to use incremental loading. The 2 variables that are most important in this case are data interval start and data interval end. And they do what you might guess. They're just the datetime objects that represent the start and end of your interval. Here's a graphic that explains what we're talking about. Airflow will take the timeline and separate that into different data intervals. Our first interval will be from February 1st to February 2nd because we said our start date is February 1 and we said our schedule is daily or 24 hours. After this first 24-hour period ends, Airflow will trigger our DAG for the very first run. And when it does, it will define these variables, data interval start with a value of February 1 and data interval end with a value of February 2nd. It's up to our DAG code as to whether it does anything with these variables or not. After that, Airflow will wait for another 24-hour cycle, at which point it will run the DAG a second time. But this time, the values of data interval start will be February 2nd, and the value of data interval end will be February 3rd. And this pattern continues for as long as the DAG is active. All right, that's a lot of theory. Let's make this more concrete. We're going to make our own DAG that processes donut orders. Our source in this case is a delicious API that gives us orders made to a donut app. Let's check out this API. The API has a single endpoint orders. We can check it out. We'll press try it out and press execute. After a second, we can see that the API is giving us some results. Here we have donut orders. It's an array of objects, and each object is a different order. The order information includes the username, how many donuts they ordered, and when they made that delicious purchase. What we'll do is create a simple DAG that processes these donut orders using incremental loading. Here's the high-level view of what the DAG will do. First, we'll capture all the orders that we can from the API and save the results in a JSON format on our local worker. Then, in our second task, we'll read those JSON files and perform a little bit of analytics. We'll just aggregate by hour to figure out how many donuts are being sold per hour per day, and then the results will be saved in a table format as a CSV file. Here's the key decision that we'll make in this DAG design. We are not going to capture all orders every time the DAG runs. Instead, this DAG will run daily, and for each run, we'll only get orders from the last 24 hours. If you think about it, if we run a daily DAG, we don't need to capture the orders from a week ago because we already have a DAG run that did that. This is the incremental loading piece or design of our DAG. This design is possible because our API has some query parameters that allow us to filter our orders by date. In our API, we can see that there are start date and end date parameters. If we scroll down a little bit just to see what's going on, we'll see that without the query parameters, we're getting orders from February 13th all the way down to February 26th. Let's test this out and filter that a little bit. Instead of starting with orders on February 13th, suppose that we just want orders from February 14th. Valentine's Day. We'll just get 1 day's worth of data by putting in February 14th to February 15th. Hit execute, wait for the results. And now we can see that our response has orders starting on February 14th, going all the way to some other time on February 14th. This is how we can get just 1 day's worth of data. By the time we're done, we'll have a DAG that looks a little bit like this with our 2 tasks. And we'll also have a series of files representing our donut orders. The first task will dump the API results into a JSON file. Let's, for example, look at maybe February 19th. Here we can see all of our orders that are made. And then the second task will perform that hourly aggregation and will give you an hourly summary for every single hour of how many donuts have been sold. Let's get to it. Let's build our DAG. Remember, we'll use template variables to capture 1 day's worth of donut orders every time the DAG runs. Here's the skeleton for our DAG. We'll use a DAG object in the context manager, and we'll later define our 2 tasks and tell Airflow which task needs to run before the other. Let's start fleshing this out. First, of course, we'll need our import statements. We'll import the datetime object, we'll import our DAG object and a few operators from the Airflow module. And we'll also import a custom Python function that's been made just for this DAG to perform that aggregation of how many donuts have been ordered per hour. Our first task will be to capture information from that API. To do that, we'll use the bash operator to execute a curl command. If you look at the curl command, you'll see that the URL is broken up across these 3 lines. And instead of using a hard-coded start date and end date, you'll notice that we're using these template parameters in these curly braces. This is standard for Airflow. If you want to use template parameters, you just use these double curly braces, and when the DAG runs, Airflow will effectively inject whatever that variable is in place of those curly braces, and then execute whatever the command might be. This is consistent with our design of our API. We can see that if we filter for a particular date, all we're doing is passing in the parameters of start date and end date with actual dates. The only thing that's different is that in this case, we're giving template variables to be later figured out. This pipe ds is just taking the date time that we have in data interval start and converting that into that string that you see here, a year, month, and day format. You'll also notice here that we're using a template variable as part of our output flag. When we run the curl command, this -o tells the command where you want the results of that command to be stored. In this case, we're storing it on our local worker in the folder data, orders, and the file name is templated to be that data interval start .json. This is what generates these JSON files that we saw before in our VS Code. Cool. So that's our first task. That's the task of getting information from the API and dumping it into a JSON file. Our second task will read that JSON file and perform an aggregation and save into a CSV file. We don't need to know the specifics of how this is done. We're basically just using pollers to read the data into a data frame and then clean it up and save it as a CSV. The thing that is worth noting is how we're telling this function what file to read and what file to write. In this case, we're using the argument templates dict and passing in a dictionary where the parameter file name is some template variable, in this case the data interval start. This is how we tell the function calculate hourly stats what JSON file to read and what CSV file to ultimately write. Of course, later we finish with the order of our tasks, and all of this together should get our DAG up and running. Now, before we do that, let's just look at a few DAG runs to see how some of these template variables have been rendered. Here I have this exact DAG, and it's been running successfully for a few days. If we look at one of our DAGs, let's say this one right here, this particular DAG run had a data interval that started on February 19th and ended on February 20th. If we look at this first task, the get orders task, remember that's the curl command. Here we can see that the curl command was rendered like so. In particular, you'll see that we're passing in the interval start of 219, the interval end of 220. Later on in the second task, remember we had that file name parameter that was passed to our Python function. Here we can see that that file name parameter was rendered as 219. And that's it. That's how you set up incremental loading. You can use Airflow's template variables in your DAG code to make sure that when your pipeline runs, you're not looking at the full data set of all the orders that could come out of your API, but instead just a small data set at a time. This particular DAG run processed data for the day of February 19th. And as the DAG runs daily, you can see that each of these is going to process data for different days. The very next day, we ran the DAG for donut orders on February 20th, and then donut orders on February 21st, so on and so forth. Now let's say that someone comes to you and says, hey, something happened in the API, those orders that we got from a week ago are just messed up, and we need to rerun the pipeline for that one day. Here's how you can do it in Airflow. Let's actually simulate that. Suppose we have corrupt data in our JSON file. Here is the JSON file for February 19th. I'm just going to say that something happened in the API and we don't have good data. We'll save that. If we don't have good data for the JSON, we also don't have good hourly summaries. We'll save both of these files and simulate what we could do to rerun the pipeline for this particular day. Back at our UI, all we need to do is to find the DAG run associated with February 19th. And in this case, I think I might be on it. Here we have the data interval start of February 19th and ending at February 20th. So this is the one that we need. To rerun our DAG, all we need to do is go back up and in the clear button, press clear existing tasks. This does what you might expect. It will clear out the tasks, which will prompt Airflow to rerun the pipeline. Oh, we already see that our JSON file has been repopulated, and now it's trying to perform the aggregation of CSV, and the CSV has been regenerated as well, with information that looks pretty decent. In Airflow, as you rerun these DAGs, I think it's best practice to make sure that you're adding some kind of notes for yourself or your teammates so that you know why this DAG ran multiple times for the same interval. We could just say that source data was corrupted, manual rerun, and save the note so that later on someone can come and see why it was that we have multiple attempts on this particular run. The UI has a few other ways to rerun a DAG. Suppose, for example, that our API was not functioning for several days in a row. If we wanted to, we could rerun those DAGs at the same time. Let's go over to our DAG runs, and let's just say we go to the beginning. Suppose that in this case, the first few days of our API were a little off and we need to rerun all of those. In that case, what we could do is click on a particular task, and similar to before, we can clear the task. This time we'll get a few more options here. You'll see that you can choose relative to that selected task if you want to clear all tasks in the past or all tasks in the future, as well as any tasks that are upstream or downstream in that particular DAG run. And as you combine these different buttons, you'll see how many tasks are going to be rerun. Let's simulate that we're going to rerun this selected task and all the tasks that are in the past. If you want, you can click on this dropdown and see the very particular tasks and the run IDs that you're going to rerun. I'm good with this, so I'll hit clear. And what will happen is each of these DAGs will be rerun. All right, through the magic of video editing, these DAGs have just completed. There we go. That's how we can use incremental loading in Airflow. All we need to do is use those template variables in our DAG code to isolate our source data to the small chunk that we care about for that particular DAG run. Again, this is more efficient because you're not reprocessing the full dataset every time. It makes your DAG runs go faster, and you're also not using as much compute resources. If you're curious about this delicious API and how you can set up the DAG to process it, you can check out the GitHub link in the description below. In the README file, you'll find the various pieces of information that you need to set up the API yourself, as well as the Airflow instance and the DAG that will process it. We're just using Docker to run Airflow in a local worker, and a few Python packages for the API and processing the results of the API. Let me know what you think. As always, if you have any questions, feel free to reach out. If you like what you see, you can like and subscribe. And until next time, happy coding.